Okay, so today we're going to be looking at more of a genetic approach to borderline personality disorder. I actually made this video earlier, and I'm going to actually try to shorten it down because it was about 11 minutes long. So I really want to cut that down so that it's not 11 minutes and it's only around 5. So we're going to run through this pretty fast. So a genetic approach to borderline personality disorder, we already looked at the hereditability aspect of it, which is a big portion of this. However, we're going to really be looking at the biomarkers and the methylation, how it can be used as an early diagnosis protocol for borderline personality disorder. So moving in, the DSM-5 criteria, which is directly from the book, and you can find in the book if you want to look further into it. But borderline personality disorder is really characterized by instability, impulsivity, impaired social functioning, and identity disturbances. And this is extreme cases. So, like as we look at in the videos and the various case studies, it's these people that have severe cases of instability, impulsivity, and whatnot. As shown in the video, the woman had issues with relationship where she completely cut out her husband from not agreeing with one thing, which is not normal, as we know. So it's really what we looked at in class, but we're going to actually be looking at the methylation, which I'll get into in the next few slides. So as we talked about before, there's really patterns in families. So you will see if you're looking at a phenotypic chart, several family members will be diagnosed if they actually went and got treatment. You'd see a good pattern in there. So you're 4 times higher when biological relatives have been diagnosed. It's a combination of these genetic and environmental factors, but it's really the traits that are inherited. So traits for instability, impulsivity, or really serotonin system. But there's really a lot of unknowns. So I'm not going to be able to explain everything, but I'm hoping to try. Even though a lot of it no one has really explained. So we do know that environmental factors account for 55%, while genes count for about 40%. And we're really going to be looking at this serotonin system. So before I get into that, uh, basically it's what we looked at, the genetic and biologic vulnerabilities, plus the trauma and whatnot, and how that leads into the borderline personality disorder. So in a study that looked at the increased DNA methylation of genes that occurred in borderline personality disorder, they looked at 14 different genes that seem to correlate between borderline personality disorder. They looked at those control and those that have actually been diagnosed. And they actually found high methylation patterns in the following genes. The HTR2A is the one that we're going to mainly be focusing on. That one actually has to do with the serotonin system. So it actually completely turns off that gene and has lower rates of serotonin release in neurotransmitters. As you can see in this figure here, which is the main reason why I actually filmed it like this, is so you can actually really look at these figures. There's highly methylated, because of the dark spots, that's why you can resolve and discuss that. There's highly methylated in the P through 10, which are the patients with borderline personality disorder, more so than the control. And then the other genes that seem to be highly methylated are those that are in anti-inflammatory and just very, very different methylation processes. However, the function and how these play a role in borderline personality disorder are not well known, and really aren't going to be the focus of this presentation. So just the basic genetics, which you probably know this from high school or whatever else, is that we have these three nitrogen bases. We have adenine, glutamine, thymine, and cytosine. We know that the C and the G always form together. You just abbreviate them. And that the T and the A always form together. A and G being both double ring, and then T and C being both single ring. So basically what it means as methylation is that there's this methyl group, as you can see right here, that attaches to cysteine. And it actually causes, as you can see in figure B, the part of B of the figure, it causes the gene to be silenced. So basically what that would mean is that in the case of the HTR2A is that the serotonin receptors actually don't work properly, which would be very interesting to look further into for diagnosis principles for those individuals that have the predisposition to the family trait patterns. Another basic one that looked into this is basically, we're going to fly through this, is that there was correlations between, in a twin study, between MDD, AUD, and DUD. So it just showed that maybe if we could combine these two studies together to see if maybe those individuals that the twins actually inherited the same predispositions, and also which in turn inherited the MDD, AUD, and DUD. As shown in these figures, it actually showed a biometric latent growth model that looked in the environmental and genetic factors, which actually showed that BPD rates predicted a greater rate in AUD and DUD symptoms. As you can see here, alcohol use disorder symptoms were higher in those with BPD, and major depressive was also high in those um, diagnosed with BPD. So the common genetic traits between the twins also contribute to the association between these. Um, so basically, the take-home message for this one was that these genetic dispositions could be related to the major depressive disorder, alcohol use disorder, and drug use disorder. So basically, the conclusion and the take-home message is that we can use these methylation principles in genetic counseling or different uh, genetic courses to possibly initiate that these individuals have this predisposition or this vulnerability, and then they can be further watched over time, um, and basically not coddled per se, but treated if they do start to show symptoms, as previously explained. I really looked at these three sources. The first one the most, as you saw, in the methylation. The second one in looking at the different substance disorders and the major depressive symptoms. The second one really, and the third one really just tied everything in. Again, I chose this so that you could really see the figures. Thank you and have a good break.